Uh, Good morning, namaste, and welcome to this fifth day session. I am Dr. Vivek Regni, the coordinator of this webinar and Director Markham at Vet Nepal. For those who are joining our webinar for the first time, uh, or might have missed the previous talks, I'd like to give a brief intro about Vet Nepal. Vet Nepal is primarily focused on sharing news, information, and knowledge in the field of veterinary science, livestock, and poultry industry. Besides disseminating the technical information and knowledge of livestock and poultry husbandry to farmers and scientific information to veterinarians and vet students, we also intend to serve as an outstanding e-platform to promote the expertise, products, service, facilities, and prestige of any veterinary-related business. This advanced poultry nutrition and feed formulation webinar aims to train the poultry veterinarians and veterinary students about the various aspects of poultry nutrition and feed formulation, from the ingredient selection, understanding of digestive physiology of chicken, understanding the nutritional requirement of chicken breed and type of birds, to least cost formulation. We have invited different national and international poultry nutritionists, professors of poultry nutrition, veteran formulators with decade-long experience, engineers and software developers as our keynote speaker to deliver their talk on the topic of their expertise. We are really thankful for your overwhelming participation and also thankful to the insightful presentation of our keynote speakers. Above all, we feel blessed to enjoy the interactive question and answer session after each talk, which has put much light on the different practical aspects of poultry nutrition that were beyond our expectation. It is a matter of immense delight to witness participants from different countries, like from Nepal, India, and also from Egypt. And likewise, the expert speaker from Nepal, India, and USA. Once again, I would like to request our participants to mute their microphone during the talk session. They please feel free to put your questions in chat box. And we humbly request the participants to appear in Zoom platform with the name with which they have registered. As we all know, this is a 6-day webinar with 3 talk sessions each day. The talk sessions for today will be number 1, feed hygiene and feed sanitation program, which will be presented by Dr. Bikas Puri. He is associated with Global Feeds. Likewise, Mr. Harjot Singh from Lark Engineering will be dealing about feed mill design and processing, and Mr. Himanshu Saxena from FOSS India will be dealing with NIR technology for precise nutrition. Without any further ado, I would like to introduce you to today's first keynote speaker, Dr. Bikas Puri. Dr. Bikas Puri is working as assistant professor at Agriculture and Forestry University, FABF. He has been teaching veterinary pathology since last 7 years. Before this, he was working as assistant professor in IAS Tribhuvan University, Pakliawa campus. Beside this, he is also a promoter of companies like Global Agro Products Private Limited, Global Hatchery Private Limited, Global Bots Private Limited, and he is actively involved in consultancy services in different breeder farm, layer farm, and feed mills of Nepal. Dr. Bikas Puri, now the floor is yours. Please proceed ahead with your presentation on feed mill hygiene and sanitation.
I think thank you, Vivek. Is my screen visible?
Yes, it is.
Okay. Thank you, Vivek. First of all, I'd like to thank you for giving me this opportunity. And I'd like to welcome you all in today's session. I have been provided topic feed hygiene and feed sanitation, and I'll be presenting on this topic for next 40 to 45 minutes. Okay. Uh, I'm Dr. Bikas Puri. Right now, I'm working as an assistant professor in Department of Veterinary Pathology and Clinics at FABF AFU Rampur. Now, let us begin with the introduction. We all know that the population of the world is increasing day by day. And if it will continue in the same manner, then it is expected that by 2050, the world population is going to cross 9 billion. So is the demand for feed. It has been estimated that the food demand will increase 2 times. It will be double what is being produced right now. Isn't it interesting? Next, interesting thing is that various studies have shown that demand for right now, the consumption pattern has changed a lot. Right now, there is an increased demand for food of animal origin. This is a good news for us, isn't it? It may be either due to increased urbanization, it may be due to increased purchasing capacity, or it may either be due to increased consciousness of people toward health and healthy living. Whatsoever, it is good news for us because with increased demand for food of animal origin, there will be worldwide growth in intensive livestock production. Being a vet, it is a good opportunity for us, isn't it? And with increased intensive livestock production, there will be increased demand for the feed. And this is a sort of challenge for the feed millers because from this point, they have to start working to meet growing demand. Not only that, the main challenge is to ensure feed hygiene. Now, what is feed hygiene? Simply, hygiene means measures or some conditions which are adapted to control the hazards. But if we are talking about the feed hygiene, then only talking about the hazards is not enough. It is more than that. Feed hygiene should ensure control of hazard. Apart from that, it should ensure production of the safe feed, and it should ensure production of the safe food. Only the agenda, farm to fork, will be alive after that. Now, what can be the hazards associated with the feed? There are numerous hazards, but broadly, those hazards can be categorized into 3 main groups. One is biological hazards, another is chemical hazards, and another is the physical hazards. Metal pieces, plastics, wood, stone, dead insects, insect droppings, all this falls under the physical hazards. Usually, physical hazards are contaminants, they are not absorbed into the system. That's why there is a very little chance of these things being introduced into food chain. But this is not the same for biological and chemical hazards. Biological hazards and chemical hazards are a serious threat both for the feed as well as for the food. And there is a higher chance of these things being introduced from feed to food. So today's mandate is that feed should be free from the biological hazards. It should be free from the chemical hazards if you want to ensure food safety. Under biological hazards comes the bacteria, virus, and the parasites. Usually, if we see feed, it is rich in nutrient. It has the right amount of pH. It has a right amount of moisture, which are conducive for the growth of bacteria. That's why chances of microbial growth in feed is high. Beside this, feed can also act as a vector for transmission of the different parasites as well as viruses. Unless we ensure or we prevent these biological hazards, we cannot ensure better productivity of our livestock. If feed became contaminated, then our livestock will get diseased, productivity will decline, mortality will increase, FCR will also increase, and this will overall affect the production efficiency. So at any cost, we need to control the biological hazards. Beside this, there's a chance of this microbial contaminated entering into the food chain by meat, egg, right? Similarly, chemical contaminants includes natural toxins. It may be plant toxin. Similarly, different other chemical contaminants like drug residues, food additives, pesticides, industrial chemicals, mycotoxins, heavy metals, right? It may be environmental pollutants, it may be radioactive waste, anything. This comes under the chemical hazard. Why feed hygiene? Why it is so important right now? Feed hygiene is necessary to produce the safe feed, and better productivity and better profitability can only be ensured once animal consume safe feed, right? Otherwise, they will get diseased, and overall production efficiency will decline, will be in loss. Next, to ensure production of the safe feed. Food safety is a public concern right now. In every newspaper, television talks, social media's pages, it is covered with different informations or different headlines related to the feed and food contaminants, right? Many times we get opportunity to hear about melanin, presence of melanin in milk and milk products, presence of dioxin in meat and eggs, emergence of unknown pathogens in livestock. Recently, 5 days back, I got one paper, and त्यसमा लेखेको थियो दानामा छैन गुणस्तर नेतृत्वकै दाना दूषित. What does this means? This means food safety, feed safety is a public concern right now, and every attempt need to be made to control it. Remember, feed is a part of food chain, and we can imagine safe food only when we can produce safe feed. Now, who is responsible and accountable for the food hygiene then, for the feed hygiene? Neither supplier nor veterinarians who are engaged in feed millings operation, they are responsible for the feed hygiene. It is the producer. This is the feed business operator responsibility to make feed free from the microbiological and chemical hazards. And he is solely responsible for all the losses which are incurred. Because if producer wish, if he is serious, then he can definitely control those contaminants by adopting different measures, which we will talk later on. Next thing, what I want to say is that feed hygiene is a collaborative effort. एउटा कुनै individual let's आएर मात्रै हुने कुरा होइन. Each and everyone who are engaged in this feed chain, they should be responsible and they should be accountable. And if we see in a feed mill, nutritionist, purchase manager, and plant manager, they can work in collaboration, they can work in synergy to enhance the feed hygiene. Next, yeah, while conducting these activities, it may incur some cost, but we should not forget feed is a part of food chain, and for production of the food, safe food, it demands some money, right? And this feed hygiene procedure, this is not a एउटा कम्पनी मात्रै तपाईँको यसको लागि जिम्मेवार छैन. यो ठुलो कम्पनी, यो सानो कम्पनी, that is not a good idea, हैन. यो सबैको रेस्पोन्सिबिलिटी हो, whether it is a big company or it is a small company. र हामीले अर्को बुझ्नुपर्ने कुरा के हो भने यो फेरि एकचोटि मात्रै गरेर हुँदैन. This procedure, this is a continuous process. बुझ्नुभयो नि? Then only we can ensure the feed hygiene, we can produce safe food. Now let us talk about the hazard analysis and critical control point. फुडमा पनि तपाईको यस्तै किसिमको इस्युजहरु थियो र त फुडमा भएका फुड हाइजिन सेफ फुड प्रोडक्सनको लागि चाहिँ मलाई लाग्छ सन् 2000 को राउन्डमा चाहिँ एउटा प्रोटोकल तयार भयो, and that protocol is known as the hazard analysis and critical control point. के भनिन्छ भने यो hazard analysis and critical control point is one of the effective measure for producing a safe food. अहिले हामीले देख्न सक्छौं विभिन्न प्रोडक्ट्सहरुकोमा लेबल गरिएको छ. It is HACCP certified, it is GMP certified, it is ISO certified. These are all the management tools for ensuring the safety of the food. Why can't we adopt the same protocols in feed? If we really want to produce a safe feed, if we are really concerned about the feed hygiene, then I think we can accept these protocols in our feed production also. Simply, this hazard analysis and critical control point, which we call HACCP, it involves, it is based upon the 7 principles. One is identifying the hazard. At first, the first work is to identify the hazard. After identifying the hazard, we need to identify the critical control points within a process flow diagram. After identifying the critical control point, we need to establish the critical limits. We need to monitor the procedure. We need to establish the corrective actions. We need to verify the procedure and record and document. These are the 7 things which HACCP says. These are the 7 principles. We'll discuss about this in later in detail. हामीले के बुझ्नु पर्यो भने HACCP को प्रिन्सिपलले चाहिँ के भन्छ भने सबैभन्दा सुरुमा you need to describe the product भन्छ. What is this? It says you need to draw a flow diagram. Process flow diagram चाहिँ बनाऊ भनेर भन्छ हैन. र यो दुईटाको आधारमा now you have to plan, make a HACCP analysis plan. र यो HACCP analysis plan को चाहिँ 7 वटा प्रिन्सिपल के हो त भन्दाखेरि identify the hazards, identify the critical control point, set critical limits, measure it, establish corrective action, verify the procedure, and record and document. Description of the product. This is the first step. यसमा के भनिन्छ भने तपाईले किन्न खोजेको इन्ग्रेडिएन्ट्स होस् अथवा प्रोड्युस गर्न खोजेको प्रोडक्ट होस्, you should know about the product in detail. You should know its specification. You should know what are the toxins, hazards associated with it. You should know intended use, how to pack it, and who is the intended user. Everything should be mentioned clearly. And this is called the description of the product, and this is the first step of ACAP. For example, this is a boiler starter feed. If you here, these are the specifications. This may be the toxins or hazards associated with the boiler feeds. Who are the intended users? Description regarding the packaging, description regarding the shelf life, and what are the precautions to follow while storing or while transportation, right? This is known as the product description. This is for the feed, and this is for the maize. These are the examples. Look, product is maize. What is the specification of the maize? These are the specifications, right? What are the hazards associated with it? These are the hazards. Who is the intended use? These are the intended use. Packaging, maybe PP bags, BOPP bags, jute bags, anything. You should mention that. And who is the target consumer? Feed mill, right? Like in this way, we need to describe the product. This is the one example of product description. Next step is development of process flow diagram. For example, if you are producing a feed, let us say it's the same starter feed for boiler, then you need to explain each and every step in detail, starting from procurement to end user. You need to write each step. You have to draw a flow diagram like this. What is the advantage of this? Once we develop this flow diagram, then we'll know the activity that we carry out in each step clearly. We can identify which are the critical control points, right? And based on that critical control points, we can set the critical limits. We can monitor whether our process is, we can monitor the procedure. We can validate it, right? So this process flow diagram is important. This is for the poultry feed. Similarly, a similar type of process flow diagram can be prepared for the ingredient purchase also, right? Starting from harvest to mandi, mandi to supplier 1, supplier 2, supplier 3, then feed mill, right? This will give us a clear indication or ideas what involved in each steps. And next thing, it will help to make each and everyone engage in each step. हैन उनीहरुलाई अकाउन्टेबल उनीहरुलाई रेस्पोन्सिबल बनाउनलाई यसले एउटा इम्पोर्टेन्ट रोल पनि प्ले गर्छ. वी क्यान आइडेन्टिफाई हु इज नट सिरियस भन्ने कुरा हैन. हेर्नुस् त मैले एउटा एक्जाम्पल यहाँ राखेको छु. अब सबभन्दा सुरुमा तपाईले के गर्नुभयो त प्रोडक्टलाई डिस्क्राइब गर्नुभयो. देन कम्स प्रोसेस फ्लो डायग्राम. त्यसपछि आउँछ के त भन्दाखेरि हेजार्ड एनालाइसिस. हेजार्ड एनालाइसिसको लागि सबभन्दा सुरुमा के गर्नु पर्यो, यो कुन प्रोडक्ट हो त हैन त्यो तपाईलाई थाहा हुनु पर्यो. इन्ग्रेडिएन्ट्स के हो अथवा कुन प्रोडक्ट हो. Based upon that, you will identify the hazards associated with those ingredients. हैन the biological hazards छन् कि chemical hazards छन् कि physical hazards छन् कि के छन् हैन. You need to identify those hazards हैन. You need to identify the severity afterward. के हो त it is going to harm only the animal, or it is going to get or it is even harmful to the human. त्यो कुरा हामीले त्यसको सिभिरिटीलाई स्टडी गरेपछि थाहा हुन्छ हैन. एन्ड दिस सिभिरिटी should be based on scientific basis. You need to give justification. Like animal ma, for example, aflatoxin ko contamination. So this is a chemical hazards. It can affect animal, right? It is hepatotoxic and carcinogenic. Justification. Is it harmful to the human? Yes, it is harmful to the human because aflatoxin YAM1 can be transmitted to food chain by milk, and it is responsible, and it is one of the important carcinogens. भनेपछि के भयो त हामीले यसको के हो त भन्दाखेरि the severity is based on some scientific evidence, right? र यसको आधारमा अब हामीले what are the control measures, how can we eliminate it, हैन? त्यो कुराहरु हामीले तय गर्नु पर्यो, हैन? फर्स्ट अफ अल त्यो एफ्लाटोक्सिन छ कि छैन भनेर टेस्ट गर्नु पर्यो इन्ग्रेडियन्ट्सहरुमा, हैन? त्यसपछि अर्को कुरा के हो त भन्दाखेरि स्टोरेजको क्रममा, हैन, तपाई के गर्नु पर्यो त भन्दाखेरि एउटा भनौं न टेस्ट योबाट हामीलाई के थाहा भयो त भन्दाखेरि हामीले एफ्लाटोक्सिन को लेभल चाहिँ एकदम हाई छ फिड इन्ग्रेडियन्टमा भने त्यसलाई चाहिँ हामीले के गर्नु भएन त पर्चेस गर्नु भएन भन्ने कुरा त हामीले यहीँबाट थाहा पायौं नि त, हैन? र त्यसको लागि के गर्ने त कन्ट्रोल मेजर्स के हो त भन्दाखेरि टेस्ट द इन्ग्रेडियन्ट, हैन, एन्ड बाय फ्रम द एप्रुभड सप्लायर्स. र यो स्टेप एन्ड अब यसको आधारमा हामीले के गर्न के थाहा पाउँछौं त भन्दाखेरि वी क्यान आइडेन्टिफाई द क्रिटिकल कन्ट्रोल पोइन्ट. कहाँ भन्दाखेरि एट द टाइम अफ प्रोक्युरमेन्ट, राइट? तर त्यो स्टेपमा गएर हामीले हेर्न सक्ने भयो. त्यो स्टेपलाई चाहिँ अझ स्ट्रेन्थन गर्नलाई के गर्ने भन्ने कुरा चाहिँ यहाँबाट अब हामीले के गर्न सक्ने भयो, सोच्न सक्ने भयो. वी क्यान मेक अ प्लान. त्यसपछि अर्को काम भनेको के हो त भन्दाखेरि अब हामीले के गर्यौं त भन्दाखेरि मानव इन्ग्रेडियन्ट रिसिभिङ चाहिँ के हो त हाम्रो क्रिटिकल कन्ट्रोल पोइन्ट हो, राइट? भने हाम्रो हेजार्ड के हो त एफ्लाटोक्सिन हो. नाउ वी नीड टु सेट अ लिमिट, राइट? मेसको लागि के भनिन्छ भने अफ्लाटोक्सिनको लेभल चाहिँ इट शुड नट बी मोर देन 20 ppb. दिस इज अ क्रिटिकल लिमिट फर अफ्लाटोक्सिन इन मेस, राइट? or let us say for the feed. Now we need to monitor it. के छ त साँच्चै नै एफ्लाटोक्सिनको लेभल 20 भन्दा 20 छ कि 20 भन्दा माथि छ कि कम छ कि के छ, कसरी गर्ने, हाउ, बाइ युजिङ कुन टेस्ट मेथड चाहिँ हामीले एडप्ट गर्ने भन्ने कुरा चाहिँ यहाँ हामीले उल्लेख गर्नुपर्ने हुन्छ. कति चोटी इच एन्ड एभ्री टाइम while receiving the ingredient, हैन? हु इज रेस्पोन्सिबल हेर्नुस् भनेपछि यसमा के छ त को रेस्पोन्सिबल छ, कति चोटी गर्ने, कसरी गर्ने र के चीज लिमिट के हो, इच एन्ड एभ्रिथिङ इज क्लियरली मेन्सन्ड, राइट? र यसको आधारमा अब हामीले के करेक्टिभ एक्सन लियो त नि, लिने त नि, हैन? र यो काम भएको छ कि छैन भनेर फेरि के गर्नु पर्यो, वी नीड टु भेरिफाई. बुझ्नुभयो नि? यो सबै काम भइसकेपछि document it and keep record.
Sorry for the interruption. Since there are some Indian participants as well, I request our respected speaker to avoid Nepali as far as possible.
Okay.
So there are some Indian participants as well. Thank you. Thank you. Sorry for the interruption.
No, you're all right, Vivek. Yeah.
Please go ahead.
Yeah. These are some examples how we can incorporate the principle of HACCP in animal feed production process, right? And if this protocol is very much successful in food industry, why not we accept this in animal feed industry? Because the principle is same, slight modification is required, and moreover, the main thing is seriousness is required for this. Now let us talk about how can we control the microbiological contamination in feed. Similarly, later we'll talk about how the fungal contaminants or mycotoxin can be prevented in the feed. The microbiological contamination, in order to prevent the microbiological contamination, uh, we need to start from the raw material selection and purchase. Contamination can occur at any point, at source, at the time of handling and storage, right? But we need to start from ingredient sourcing and purchasing. For this also, what I recommend to you is to follow a HACCP principle. At first, identify the product, describe it, which product you are going to purchase. After that, prepare a process flow diagram. It will help you to identify the critical control point. Based on that critical control point, establish a critical limits, then set or make a hazard analysis. After making a hazard analysis, identify what are the tests, what is the limit, what are the tests to be carried out. Accordingly, validated it whether all the procedure has been followed or not, and keep record. You need to carry out a quality, all the ingredients which are coming into your factory should pass the quality control, both qualitative as well as quantitative. Based on that, prepare a history of the supplier. While making a purchase, ask for the specification with the supplier. If he is able to provide you a specification, then he knows the product well. Chances of getting engaged in fraud activities is less in such situation. If he is unable to provide a specification, he is not well aware about the product. Okay. At that time, you may need to provide him the specification and be strict. Ask him to the product should meet the designed specification. Once material reaches into your factory, go for the quality control examination. Analyze both the qualitative as well as quantitative, make a qualitative as well as quantitative analysis. Based on that, you make a history of, you prepare a history of the suppliers, and always make purchase from the valid supplier only. Next is the formulation. While formulating, this is a role of a nutritionist. Here, nutritionists have an important role. And at the time of formulation, as far as possible, we need to avoid ingredients which harbor a high level of microbes. Usually, ingredients of animal origin, they have a high microbial loads, right? But same time, we shouldn't forget these ingredients of animal origin, like embryo, fish meal, blood meal, right? They are rich in protein, and beside that, they are cheaper also. So in these cases, it is best to implement a quality control program rather than just discarding the product. Next, what I would like to say is that which culprit, which are the culprit ingredients in your opinion, veg or non-veg? In my opinion, both veg as well as non-veg, they can be a source of microbial contamination. The main thing what we have to do is we need to find out the relative risk factor. Maize, soya, they also have some level of microbial microbes. त्यो असम्म तपाईँ त्यसमा माइक्रोब्सहरू हुन्छ हैन, But if we make an analysis, percentage of microbial load is very high in ingredients of animal origin as compared to ingredients of plant origin, right? But it doesn't mean that they are devoid or they are free from the microbial contamination. They do have, but load is less. But if you look from the inclusion perspective, the inclusion rate of prawn is around 60%, 50 to 60%, where that of the protein source is around 25 to 30%, right? While that of meat is just less than 5%. Though protein of animal origin have a higher microbial load, but due to lower inclusion rate, their relative risk factor is less. We should not forget this. This is one important consideration that need to be made while carrying out a formulation. So it is not a better idea always to discard the protein of animal origins or ingredients of animal origin, considering it has a higher microbial load. Rather, we need to look for the relative risk factor. These are the guidelines limit for the microbial contaminants. In cereals, enterobacteria limit should not be more than 3.5. E. coli, it should be less than 1. Salmonella should be negative. Mold less than 3.5. Yeast less than 3.5. Right. Similarly, for the processed raw material like soya, the enterobacteria count should be less than 1. E. coli should be less than 1. Salmonella, it should be negative. Mold, it should be negative, less than 1. Yeast, it should be less than 1. Similarly, for the mass feed, and it should be enterobacteria count should be less than 3.5. E. coli count, it should be less than 1. Salmonella, it should be negative. Mold, it should be less than 3.5. Yeast, it should be less than 3.5, so on. Now, this guideline limit will help us to set critical limit in our hazard analysis, right? And now, next is prevent contamination. Strict biosecurity regimes has to be maintained in a feed mill. We should control the rodents. We should control the entry of the wild birds because they can serve as a vector for bacteria. They can serve as a vector for different viruses. We should control the unnecessary movement of packers and people because they also serve as a vector for microbial contamination. Next, we should control the dust, and we should follow a proper sanitation program within a feed mill. Feed mill premises should be clean, not only outside but also inside. Both inside to outside, both should be free from the dust. It should be clean and tidy. But it is very hard to get this. Reduce the microbial contamination in the plant. Reduce the microbial multiplication within the plant. It can be done by developing a process flow diagram. Start from the beginning till the end, identify the each process, prepare a flow diagram. This will help you to discover the microbial growth niches. Accordingly, you will also find out by developing a process flow diagram, as I have shown previously. It will help you to identify where possible contamination can occur. Accordingly, you can adopt decontamination procedures, right? You should look for the hotspot. And as far as possible, an attempt need to be made to make the feed mill and your premises dust free. Look, this can be the situation inside the conditioner, inside cooler, inside the feed conveyor, inside the mixers ribbon, right? Every attempt, right? And these are the sources of recontamination. So a protocol need to be designed for proper sanitation. Then only we can ensure feed hygiene. Other recontamination points include bucket elevator, finished product silo, finished bulk discharges, trucks, bags, bulk feed and bags on farm. These are the points where decontamination can occur, right? Bacterial control. An effective microbial control program includes elimination of the microbes or bacteria, prevent recontamination, and improve feed hygiene and biosecurity. Microbes can be killed or bacteria can be killed by two processes. One is thermal processing and another is by adding chemicals like organic acid or chemicals like formaldehyde. Recently, different plant extract phytochemicals has also been developed, which can be used along with organic acids to kill the microbes. Standard pelleting and heat treatment can be and thermal processing. Standard pelleting temperature and time are not sufficient to kill the salmonella. Special equipment are now being installed in feed mill to achieve minimum log 6 reduction in the salmonella, like conditioner, hygienizer, etc. It has been this is a good example. Here we can see the combination of the heat, moisture, and time, which is required to achieve zero salmonella. This study clearly showed that the temperature of 85 degrees Celsius at 15% moisture is efficient to reduce salmonella to 90% within 1 minute. यदि तपाईको टेम्परेचर 74 डिग्री सेल्सियस छ भने 10% moisture it required 79 minutes to kill the bacteria, right? If temperature is 74 degrees Celsius, moisture percentage is 12, then it will take around 12 minutes to reduce or to kill 90%, right? And if the temperature is increased, keeping the moisture constant at 10%, 15%, and 20%, then it requires around 3 minutes to kill 90% of salmonella. Similarly, if temperature is 85 degrees Celsius, then we can kill 90% of bacteria in 1 minute, provided moisture or conditioning moisture is 15%, 14.5 to 15%. So what I recommend is that if you really want to produce a safe feed, then the conditioning temperature should be 85 degrees Celsius. Moisture should rise up to 14.5 to 15%, but it should not get hold in a conditioner for more than 1 minute. Because, yeah, we can by applying heat, we can completely kill the microbes also. But if we increase the temperature to 85 degrees Celsius, and if we allow feed to remain in conditioner for more than 4 minutes, then at that time, it is sufficient to kill almost all the microbes. But remember, we shouldn't forget that if we rise temperature more than 85 degrees Celsius, and if we allowed feed to remain in conditioner for more than 1 minute, for more than 4 minutes, then at that condition, yeah, it will decrease the throughput. That means our production will decrease. Next, um, the proteins get denatured at high temperature, and another loss is that enzymes as well as vitamins which we have added in the feed, they will also get destroyed. That's why high temperature always is not beneficial. We need to be very cautious. The conditioning temperature should not exceed more than 85 degrees Celsius. Feed should remain in a conditioner for less than 1 minute, and conditioning temp and moisture in the conditioner should rise up to 15%. Then only we can sufficiently reduce the microbial load to 90%. But complete zero, our atoms should not be complete zero. If we increase the temperature, then we will destroy the feed. Beside heat treatment, we can also add the organic acids in a feed. Adding organic acid, these organic acids are efficient in killing the salmonella and other microbes if they are used at a correct dose. The various research have showed that organic acid usually at lower doses are not so efficient, and in fact this is in practice right now. हामीले organic acids यदि use गर्ने हो भने the inclusion rate should be more than 5 kg, and in some cases it should be more than that. But we should be very cautious while using the organic acid, because organic acid is corrosive in nature. Beside this, if we increase the concentration of the organic acid in a feed, it will decrease the palatability of the feed also. Next, adding organic acid may not solely solve the problem, because there are some ingredients in feed like calcites and they can buffer the activity of the organic acids, so that their efficacy will get reduced. Then what to do? In this case, we can. And next thing, these organic acids, they do not have broad spectrum. They are effective to the gram-negative bacteria, but not so effective to the gram-positive bacteria. I already said these are corrosive in nature, and if we increase it at higher concentration, if we use it at higher concentration, then it is going to affect the palatability, right? That's why just adding organic acid may not solve the whole problem. Now there is another concept of decontamination by using the chemicals, that is use of formaldehyde in feed. This formaldehyde is a broad spectrum. It has a broad spectrum activity. It is effective for both gram-positive as well as gram-negative, and not only to the microbes, but it is effective for the molds, protozoa, and viruses. When used in combination with the organic acid, this formaldehyde can effectively reduce the microbial load, and the protocol for sanitizing feed and feed mills. Usually in feed mills, this protocol can be used on regular basis at a certain interval in order to sanitize the feed mill. For this, we can add 5 kgs of formaldehyde plus organic acid blend in premix and premix it with corn or wheat rather than with TORB or rice polish, because corn and wheat, they are more corrosive, they have more abrasive property, right? That's why proper sanitation will take place. And after and usual practice is to back again next day in the morning. Minimum 8 hours gap is recommended. के भन्छ भने after using formaldehydes and organic acid, हामीले यसरी सफा गरिसकेपछि we need to leave the plant at least for 8 hours, so that this formaldehyde and organic acid will get chance to react on the microbes and reduce their number. Now, these are the now to avoid the mycotoxin formation, following consideration can be made, and usually we need to consider two things: one at the time of purchase and one at the time of storage. Always while procuring the ingredient, the moisture we should evaluate the moisture content. The moisture content of the ingredient should not be more than 14%. Better if we can get moisture less than that, because lower the moisture content, lower will be the chance of growth of mold, lower is the chance of mycotoxin formation. Beside this, while purchasing an ingredient, we need to develop a specification. We need to ask the percentage of the broken mesh, and all insect infestation should be nil, because if the grains are infested with insect, then it makes the inner surface exposed to the environment. As a result, chances of growth for mold is high. Broken grains are also a source of mycotoxin. Therefore, their percentage should also be limited in the ingredients. Beside this, at the time of storage also, we need to be very cautious. Water activities should be minimized, and while storing the ingredient, we can mix it with some sort of liquid acidifiers, which are now available in the market, and we can store it in a silo. And this is the safest way to control the mold inhibitor, but we should always consider the water activity. We should try to minimize the water activity as far as possible. Next is in finished feed, prepared feed, we need to use some sort of toxin binders in order to control, and we should use the mold inhibitors, and we should use the mycotoxins, mold inhibitor to prevent the growth of mold, and mycotoxin to absorb the preformed toxins, right? Similarly, we should prepare feed in such a way that the moisture content of the feed should not exceed more than 12%. Higher the moisture percent, higher is the chance of mold growth, and higher is the chance of mycotoxin formation. These are the guidelines for different mycotoxins. This can be which we can adopt in our critical limits. And right now is a mycotoxin. Toxin binders, different types of toxin binders are available in the market. But while selecting of toxin binders, we should select such toxin binders which have a broad spectrum, right? Like there are some toxin binders which are based on clay, like bentonite, zeolites, aminosalicylates. These are the clay, right? This clay-based toxin binder, they are effective in controlling the aflatoxin, but they have a very little efficacy for the other toxins like T2 and ochratoxins. Similarly, some toxin binders contain the cell wall. This cell wall have some pros and cons. This cell wall have a lower inclusion level than the clay. And they are effective not only to the aflatoxins, but aflatoxins, but also they are effective against T2 or ochratoxins, the zearalenone, right? So in my opinion, it is better to use combination of them both, clay as well as cell wall, so that we can have a better coverage. Conclusion: no single action or no individual player can ensure feed safety. It is a collective effort. Each and everyone who is engaged in feed chain, they should be responsible for this. It required the commitment from all the stakeholders. Feed safety is a shared responsibility along the whole supply chain and production chain. And key element is each and everyone who is engaged in this production process or feed chain should be accountable, and they should take it as their responsibility. Thank you very much.
Thank you very much, Dr. Bikas, for your wonderful presentation. Now, uh, uh, I guess participants must have developed a greater insight to the feed mill hygiene and sanitation after this presentation. Some might be having questions in their mind. Please feel free to put your question in chat box, or you may simply unmute your microphone and ask the question.
Hi, this is Omkar Singh. Just wanted to know, I mean, I don't know whether it would sound like an absurd, but that is more, I think it will be more like making sense commercially. If we take most of the precautions, I don't want to say all the precautions or lesser of the precautions. If you take most of the precautions, what will be the price difference in feed and what will be the impact on FCR? I'm taking both the side into consideration. 100% the price of feed will be increased.
Right, right.
And see, I mean, I am of a opinion. Price of a feed is a relative term. Like you can't give all the answers to the feed price. Like for example, if the soybean price goes from 35 rupees to 95 rupees, which happened last year, we all had burnt the of this case. We all suffered because of this. Maize prices, which went from maybe 20 rupees to 28 rupees, we all paid through our nose.
Right.
And because of this, the feed cost went high by 20 rupees a kilo. Right. We all paid the price. But taking all those precautions, I don't think it will be costing the feed even by 20 paisa per kilo, or maybe a 5 paisa per kilo, taking all the precautions. Just because it is in my hand, so I am not taking it, and that price rise was not in my hand, so I am I'm just adjusting mine. So considering my both the examples, just wanted to know, if you take mostly all the precautions, I will not say all the precautions at all the level, I think, which is sometime possible, sometime not possible, what would be the impact on the feed price? Number one. My question is, number one, what will be the impact on the feed price? And after taking all the precautions, what will be the impact on the FCR? Because I consider this expenses towards taking all the HACCPs, what you call that, precautions and all. I take it as an insurance cost. I mean, part of your curriculum, part of your organizational, what you call that, standards. I take it as an insurance cost, like how we take insurance cost, so that it is not that I'm paying it it is paying in case. So the same cost of taking all HACCPs, what you call that, precautions. So these are all insurance costs. This will impact on the feed cost, no doubt about it. But how much it impacts and what is the FCR conversion reduction you may see?
In my opinion, what I would like to say is that HACCP principles, I don't mean to say we should adopt more expensive tools. Rather, we can stand on the HACCP principles. We can
okay, let it be moderate. I mean, we will begin with simple, moderate, and probably to the highest level in coming few years, no doubt about it.
What I want to say is that it will definitely affect it is going to increase the price of the feed to some extent. But
okay.
Yeah, but FCR will definitely will get better FCR. FCR will get decreased by some points. But more than this is not about the matter of the price. It is not about the matter of the FCR only. It is matter of the food safety and public concern, and which is the major issue right now. It is
No,
going to be
I understand
yes,
psychologically very well, but
yeah,
the problem is poultry farmer understands everything in the value of money.
yeah, yeah,
So to make
yeah.
him lure to understand that it is not 100%, it is the responsibility of
Mm,
each and every owner to to go. I mean, this is like a mandatory by the government or by the maybe any human society that we
mhm,
should be taking all those care. It is a
mhm,
mandatory. For
mhm,
example, अगर आप किसी एक farmer को पूछो, are you going to eat a rat bitten glucose biscuit? No, he will not.
mhm,
So why should a bird should eat a rat eaten feed and all?
mhm,
So
mhm,
that is what in the same connection I'm just saying the farmer language. If at
mhm.
all
No, no,
he
no.
understands, if at all he understands that it is going to be little expensive on the feed,
Mhm,
but at the same time he is going to recover lot of money in FCR.
mhm,
So this thing will come into system.
mhm.
So,
Yeah, I mean to say the
any
same.
by chance you
Yeah.
can give
Mm,
how much of FCR it may reduce?
mhm,
Maybe a 0.01%, maybe a
mhm,
point. I mean,
mhm,
like for example, if you are getting a CFCR of say around 1.6, by taking this on a regular basis, can I see the change in FCR to even 1.59?
one slight difference will be there in the FCR.
I'm just trying
You are
to add
perfectly
one
correct.
scale.
Yeah.
I'm just trying to add one scale. Just trying to add one scale.
Onkar sir, what I want to say is that uh yeah, pardon please.
Please carry on.
Yeah, Onkar sir, what I mean to say is that yeah, yeah, there is a FCR there will be slight difference in the FCR, but
Okay.
later sooner or later this feed hygiene issues is going to grow bigger and bigger. And here what I mean to say is that we should not have to spend a lot for the following this HACCP principle. And, while preparing this while going through the HACCP principle, what I came to know is that it doesn't say more. It said just grab the product. While making a purchase, ask for the specification. You you prepare one SOP, and based on that SOP, make a procurement. And right now also we are making a procurement, but now procure based upon the data,
Okay.
standing on some protocols. Next,
Okay. Okay.
whatever you are doing while producing a feed, prepare a process flow diagram and try to identify what are the hazards associated with this. Analyze the hazard based upon its severity, and categorize it. Which one has to be correct first? Which is of categorize is based upon its severity, right, sir? And
Sure.
based on
Sure.
point, the critical control points, and try to mitigate or try to set limit for those uh, further hazards, right?
Okay.
And
Okay.
adopt the simple monitoring tools, right at present also. While making a purchase, we are making a quality analysis, we are carrying out a quantitative analysis, right, sir? Carry out the same protocol. Just what I mean to say is that um, sooner or later the system is going to get changed. People are becoming more and more concerned about the food safety. That's why from very beginning, from right now onwards, we need to focus on feed hygiene. And yeah, and while considering the feed hygiene, um, why not to follow the HACCP principle? You are right, sir. Right now, it is costing a lot for us, but later, uh, feed hygiene will be a great issue.
Okay. Thank you very much for your question, Singh sir, and thank you very much for the satisfying answer. And I can see uh, uh, Mr. Allison, his question. I think it would be better if we discuss in the protein sources, but still, since the soybean prices is high, maybe you can handle the question. Is there any substitute for soybean?
Yes, soya is a source of protein, and right now we have a lot of other alternative sources of the soya, like we have a mustard cake, we have sunflower cake, we have til cake, we have DDGS, which we have. We can also use animal sources of the protein like MBM. Uh, uh, yeah, there are a lot of and recently the concept of insect meals. These are also growing. Yeah, for the soya, we have its alternative like fermented soya also, but fermented soya insect meals, though they are good and they have a higher digestibility, but they are quite costlier. And so if we are really interested to produce a least cost based formulation right now, it may not be the better choice option.
Thank you. Uh, um, I think there is, I think more than a question, it is a view from Dr. Rajkumar Arak. Sir, if we consider all these things, definitely it affects FCR, and there is more chance that FCR will be less, and also medicine cost will reduce. Ultimately, the chance of farmer will be in profit. So maybe it was related. Thank you for your views, Dr. Rajkumar. Maybe it was related to the earlier discussion. Thank you very much for your valuable views. And now I think our second speaker has already joined. I would
Mhm.
like to once again. I would like to take this time to thank Dr. Bikas Puri for your generosity, for your valuable time, and out of your busy schedule, you managed to give help us on such a short notice. So thank you very much. Thank you for the insightful talks and all the answers to the questions raised by our enthusiastic participants. We look forward to cooperating with you in future always to share the information, knowledge, expertise, experience, whatever you have for the benefit of global, national and global livestock, poultry and feed industry. Thank you very much, Dr. Vikas Puri.
Thank you, Vivek. Thank you
Thank
for the
you.
opportunity.